Hi everyone, and welcome to another lecture presentation of Math 125. Today we will be looking at exponential equations. Basically we'll be talking about solving exponential equations, and this can best be done by looking at some examples. So I have 4 examples lined up over here that I'm going to solve, and hopefully you can learn the skill of solving such equations. So let's look at the first example over here. I must mention though that there is an important property that will often be helpful to recall when solving exponential equations, and that property says a to the x, whenever a to the x equals a to the y, if the bases are the same, then the exponents must be the same as well. If the bases are the same, then that implies that the exponents are the same as well. So now looking at this particular example over here, 5 to the power of x minus 1 compared with 125. Well, maybe what we may want to do over here is to rewrite this equation such that we have the same base to be able to apply the property in this particular case. So this would be 5 to the power of x minus 1. Well, 125 is the same thing as 5 multiplied by itself 3 times, which is the same thing as 5 to the power 3. And lo and behold, as it is right now, we can apply the property because the bases are the same. By virtue of the bases being the same, that implies by the property that the exponent x minus 1 actually equals the exponent 3. From this, we can solve for x by adding 1 on both sides, so x must equal 4. So x equals 4. And I'm sure you can see this satisfies this equation. If x is 4, we have 4 minus 1, which is 3. 5 to the power 3 is 125. So this would be our solution for this particular equation. In this particular example over here, well, fortunately the bases are already the same, so by this property over here, our important property, this implies that the exponent x squared minus 1 actually equals the exponent 1 minus x squared, 1 minus x squared. So from this we have to solve for x. So how do we go about this? Well, we need to export, make sure the x terms are on one side and the constants actually basically just need to make one side to be 0. We need to make, I'll take that back, we just need to make one side of the equation to be 0, and you can do that by adding 1 on both sides and subtracting x squared, or subtracting 1 and adding x squared. I'm going to add x squared, for example. If you add x squared on both sides, so this is gone, we have x squared plus x squared, which is 2x squared minus 1 equals 1. Now I need to export this one to the other side. It's positive. To do that, I need to subtract 1 on both sides, so minus 1. So that's 0. So we now have 2x squared minus 2. Minus 1 is minus 2 equals 0. So from this, we can divide by 2 across. So divide by 2, divide by 2, divide by 2. So we end up with x squared minus 1 equals 0. Well, x squared minus 1 is a difference of 2 squares, x plus 1, x minus 1, if you will. Or you can just add 1 on both sides, plus 1, so x squared equals 1. Now you take the square root. Whenever you take the square root, you will wind up with 2 results. So x would be what? Plus or minus 1. So that's our solution in this particular case. So our solution over here is that x has to be 1 or minus 1, and that will be our solution. And again, you can check. If x were positive 1, then this would be 1 squared, which is 1 minus 1, 0. 6 to the power 0 is 1. If x were 1, 1 squared is still 1, so 1 minus 1 is 0. So if 6 to the 0 equals 6 to the 0, or equivalently 1 equals 1. If x were negative 1, because x is squared, we'll get the same result. We still have 1 minus 1, which is 6 to the 0, and 1 minus 1 over here, which is 0. So 6 to the 0 equals 6 to the 0, 1 equals 1. So both of them, x equals 1 and x equals negative 1, satisfy this equation over here, and hence they are our solutions for this particular problem. Now, looking at this example over here, things are a little bit different over here in that the bases are not the same, and we probably cannot rewrite 3 in terms of 5, for example, or 5 in terms of 3 as a base. So, but basically what we can do over here, we can apply the laws of logarithms. Remember, if you have the log of something with an exponent, you can pre-multiply by the exponent. But the thing is, we don't even have the log over here, so we first have to introduce the log. it's an equation, remember. Whatever you do on one side of the equation, it has to be done on the other side of the equation as well. So I'm going to introduce the natural log on the left hand side, so natural log of 3 to the power of 2x minus 1. I have to do the same thing on the other side, natural log of 5. Now I have the log of something with an exponent. So by the laws of logarithms, one of the laws of logarithms, I can pre-multiply by this exponent over here. So multiply 2x minus 1 times natural log of 3 equals natural log of 5. Now what I need to do is distribute. What this is, natural log of 3 is a constant. So ln 3, natural log of 3 times 2x, that will give me 2x natural log of 3. Natural log of 3 times negative 1, that's just negative natural log of 3 equals natural log of 5. So now I'm trying to solve for x. I can do that by adding ln 3, natural log of 3, plus ln 3 on both sides, plus ln 3. So this is gone. I'm left with 2x ln 3 equals ln 5 plus ln 3. And now I'm trying to solve for x. ln 3 is a constant and so is 2. So I can divide by 2 ln 3 across, divide by 2 ln 3 across. So now what's left is that x must be ln 5 plus ln 3 over 2 ln 3. And that's the exact solution for this particular equation. If you wanted to find an approximation for this equation, then you'd have to evaluate this using a calculator, which is easy because this is log base e. That's the ln function on a calculator. So ln 5 plus ln 3, get a result and divide that result by 2 ln 3. That should give you the decimal approximation of this solution. Finally, looking at this example over here, this is an exponential equation. The base is a number, the exponent is a function of a variable x to be precise, but this is more like quadratic in form. So in this particular case, we just have to notice that we have 3 to the 4x and 3 to the 2x. We can solve this by letting let y equals 3 to the 2x. What would y squared be then? Y squared will be 3 to the 2x squared, which is 3 to the 2 times 2x, 3 to the 4x. So this is y squared. So the 3, so this 3 to the 4x actually is the same thing as y squared. And 3 to the 2x, so minus, which is this negative sign. We said let y be 3 to the 2x, so minus y, minus 6. That's an easy equation to solve. It's a quadratic equation. How can we solve this equation? Well, we can solve this equation by looking for two numbers whose product is negative 6 and the sum of the numbers is negative 1. In other words, we are looking for two numbers which when multiplied together will give us a result of negative 6, but when added together they will give us a result of negative 1. And those numbers happen to be negative 3 and positive 2. So you have y minus 3 multiplied by y plus 2 equals 0. Whenever two things are multiplied and the result is 0, at least one of them must be 0. So y minus 3 is 0. Or y plus 2 is 0. From this we get that y equals 3 by adding 3 on both sides, and from here we get that y equals negative 2 by subtracting 2 on both sides. But now this is not our solution because our original equation was in terms of x, so we need to convert this back, rewrite this in terms of x. But what is y? Well, y from here is 3 to the 2x. y is 3 to the 2x, so y is 3 to the power of 2x equals 3. 3 is the same thing as 3 to the power 1. So therefore, by our important property over here, the bases are the same. So that means the exponents are the same. So since the base 3 is the same for both, it means the exponent 2x actually equals the exponent 1. So from this we can solve 2x equals 1. Divide by 2, so therefore x equals 1/2. That's our potential solution over here. How about this one over here? Over here, y equals negative 2. Well, y is 3 to the power of 2x equals negative 2. Well, this will not give us a solution because there is no exponent of 3 that will give us a negative number. There is no exponent of 3 or any positive base that can ever give us, any base for that matter will give us a negative result. So this will not give us any solution. We cannot solve this. This cannot be solved anyway. So the only solution we have is x equals 1/2. And that concludes this section.